Hello everyone, my name is Dong Kim. I'm a senior researcher at the Data Science Group of Institute for Basic Science. The paper I'll be presenting today is titled Dual Attentive Three-Way Embedding for Customs Fraud Detection, in short, DATE. This is a joint work with National Chongkung University, World Customs Organizations, and Nigeria Customs Service. For those who are not familiar with this area, I'm going to spend a 5-minute overview and then we'll go into the technical part. So what is customs and what kind of problems are there? Customs are government authorities responsible for controlling the flow of goods and passengers across borders. By doing customs control, customs administration collects customs duties and taxes from traders. To secure government revenue without interrupting legitimate trade flows, customs administrations around the world strive to develop ways to facilitate customs control. According to the World Customs Organization, around $20 trillion worth of imports and more than 1 billion passengers are cleared globally in 2018. Given the astronomical volume of cross-border flows, how to control less but better is the main task of customs administration. Naturally, the problem of custom selection becomes important, and this is where AI can help. Then what kinds of transactions should they select for inspection? This would be our problem. Inspecting suspicious items, in other words, detecting customs fraud could be the answer. Customs fraud is a term for an action which companies and individuals trying to evade tax payments in connection with the importation of goods into the country. You might have seen the following news on the internet. Vietnam Customs detected customs fraud attempt with falsely declared code and tax rate of goods, leading to a shortage of more than billions of Vietnamese dong in tax. New Zealand Customs investigate $18 million amount of smuggled cigarettes, which are said to be importing furniture between 2015 to 2018, but with no mention of any smokes. Besides, cigarettes were often manipulated as furniture to get a lower tariff rate. Recently, unapproved COVID-19 treatment capsules and test kits were seized in US Customs. As we have seen, some traders intentionally manipulate some declaration details to avoid from customs duties and even smuggle the goods. Individuals should also be aware of misclassification when they are shipping products from overseas and declare it for customs clearance. For example, television should be charged with 8% tariff rate under the HS6 code 852859, but people can easily make a mistake by declaring it as a monitor and vice versa. There are several types of fraud, such as undervaluation of trade goods, misclassification of HS6 code, manipulation of origin country, smuggling without declaration, and overvaluation of trade goods. In this paper, we focus on detecting the first 3 cases of fraud, where machine learning algorithm captures the erroneous input from import declarations. By detecting them, customs administration can keep the taxes that they need to collect. Therefore, the customs selection system should work in a way that it delivers the most suspicious items to customs officials, so that manual inspection process can proceed. To detect frauds better, customs administrations around the world strive to develop ways. Some customs administrations, like Brazil or Korea, have successfully adopted machine learning models in their fraud detection systems. But many administrations are planning or requesting international support. Recently, the World Customs Organization has started looking into the potential of machine learning and making the efforts of building data analytics capacities. The good news is that import declaration follows the same format. Thanks to United Nations, more than 90 countries are using integrated customs management system called ASICUDA for international trade and comply with international standards. You may probably understand what import declarations are in context, but let me explain it briefly. An import declaration is a statement made by the importer or the agent providing information about the goods being imported. The import declaration collects details on the importer, how the goods are being transported, the tariff classification, and customs value. In this table, we mention them as importer ID, declarant ID, country code, tariff code, quantity, and its FOB value. Then the customs duty is calculated by taking into account the shipping value, which includes the expenses of imported goods, insurance, and cargo. In this table, custom duty by initial declaration is mentioned as total taxes. The duty is to be paid at the time of entry. Most countries levy custom duties on all the imported goods depending upon their value in the market. There are very few products that comes with no duty at all. Among all trade volumes, some items are being inspected. If the item turns out to be fraudulent, then its binary label is marked as 1 with additional amount of tariff. Here we called it as revenue. Therefore, the custom selection model will work by predicting each transaction's illicitness and its expected revenue after inspection. Here's the example customs clearance scenario with 10,000 items. Among them, we have to select 10% of items that require inspection. For explainability, we show item description, declared price, and the name of the importer as features. The AI analyzes the input features of each item by comparing it to relevant historical data. It then predicts each item's illicitness and sort every item in descending order. For instance, AI concludes the $50,000 Ferrari Spider is suspicious since it is considered as an outlier from its price distribution. On the contrary, for bundles of water, $6 is a reasonable price, so its chance of being fraud is nearly 0. Here are the inspection results of these example items. As we thought, the Ferrari turns out to be fraud. The original price of it was $350K, which is $300K larger than the initially declared value, $50K. Consider that the tariff rate is 30%, customs administrations were able to seize $90,000 of additional duties. Therefore, the performance of the AI-based custom selection algorithm can be compared with manual inspection result by customs officials. The first 3 matrix, precision, recall, and revenue at N% show the performance when inspecting N% of total trade. To be more specific, precision at N% indicates the proportion of illicit items among all inspections. Recall at N% is also called as a seizure rate in customs. Revenue at N% indicates how much tax the customs administration can collect by inspecting N% of items. The other 2 matrices, AUC and F1 score, measure the overall prediction results by comparison with ground truth binary labels. This paper employed transaction-level import data from Nigeria, a partner country of WCO. More than 1.9 million import trade flows from 2013 to 2019 comprises the data, and they were anonymized. It is worth noting that every customs is subjected to detailed inspection, which means that they are currently achieving 100% inspection rate. Hence, illicit and legitimate transactions are accurately labeled in this complete log, except for the case of smuggling. Nigeria Customs would like to see the effectiveness of the custom selection model in 2 stages. For offline testing, we split our 5 years import data on temporal basis. We used the first 4 years as a training set, and the last year, 2017, is used as a testing set. Then we plan to deploy and confirm the efficacy of the algorithm in a live system. Currently, we are testing our model in weekly data and providing prediction results. Next, we'll deploy our model in a system, inform the model prediction to officer, and check whether they perform better in detecting frauds. In the last phase, Nigeria Customs Service will reduce the number of inspection based on the model prediction. Great, now let's move on to the technical part. Our model is called Dual Attentive Three-Hour Embedding, in short DATE, which consists of 3 stages. The first stage pre-trains a tree-based classifier to generate cross features of each transaction. The second stage is a dual attentive mechanism that learns both the interaction among cross features and the interaction among importers, HS codes, and cross features. And the third stage is a dual task learning by jointly optimizing illicitness classification and revenue prediction. First, let me explain how we designed the feature vector X from the import transaction T. As we saw in the previous slides, each transaction consists of several numeric features and categorical features. Between numeric features, such as quantity, item value, and total taxes, we explicitly made some non-linear relationships such as unit value, value per kilogram, unit tax, as well as face ratio. We also added some binary risk indicators from categorical variables such as importer ID, declarant ID, HS code, and countries of origin. This process helped us to save huge computation cost of handling sparse categorical variables. We used the gradient boosting decision tree to process the feature vector X. A decision tree is an effective method to express high-order cross features from the original features. Each internal node split a feature into a decisive space, and a decision passed from each subtree becomes a cross feature that combines multiple feature ranges together. To further encode the value, we project each feature into a learnable embedding vector. This process enables to map similar features in a nearby points in the embedding space. Then we present a dual attentive mechanism. The first attention, a leaf-wise self-attention module, is developed to model the interaction between cross features. To achieve the goal of modeling different aspects of interactions, we utilize multi-head self-attention. In this way, we learn the contributing weights of cross features derived from different trees. The second attention network considers the importer ID and item identifier to model the tri-intersection among cross features, importers, and items regarding a given transaction. The attention weights can reflect which cross feature is more significant in determining illicit behaviors concerning a given importer U and item C. Fraudulent behavior highly depends on who is importer and what is the item inside. So we combine the obtained transaction representation with the importer embedding and the item embedding. For unseen importers and new items, we initialize the embeddings to be zero vectors. By projecting unseen ones into the same space shared with cross features, their embeddings are encoded with useful clues on illicitness. Finally, we propose a dual task learning method to identify illicit transactions with higher revenue. The final output Y head classification is the predicted probability of a transaction being illicit, and Y head revenue is the predicted raised revenue value of a transaction. The final objective function is given by this formula, where the cross entropy loss is used for binary classification and the mean square loss is used for raised revenue prediction. We compared date with 6 different baselines. The first 2 baselines, price and importer, are the widely used targeting method by selecting in the order of the most valuable transactions and the fraudulent importers respectively. The second one, iForest, is a tree-based anomaly detection algorithm. And TEM is a state-of-the-art tree-enhanced embedding model with attention network. Both outcomes of our model using Y-hat classification and Y-hat revenue are reported as date class and date revenue. We can find that date class model is far ahead of other baseline in all measures except revenue. And we can also confirm that date revenue is the most effective method to guarantee the most significant revenue for customs administration. To validate the contribution of each component of date model, we conduct an ablation study by examining the performance after removing each component. Here we can note that the step of fusion, the third one, is absolutely necessary because it simultaneously learns the correlation among cross features, importers, and items so that various behavior of importer and items can be distinguished. Since we have multi-year amount of import, we conducted the experiments by varying the length of the training data. From the left figure, we conclude that the richer the training data, the less new information is acquired. And from the right figure, the prediction performance rapidly increased until about 2 years of past data are secured. We also break the test set into several subgroups of importers and HS codes. Notable result is that date achieves a high performance for unseen importers and unseen items, although their illicit rate is higher than the usual cases. To demonstrate the interpretability of date model, we perform qualitative studies to list the comparison between illicit and licit cases with their corresponding cross features. We select the top 2 significant cross features based on the highest attention score. The result is quite convincing. For the illicit case, a used car from Toyota is pointed out because its initially declared tax ratio is very low, 0.18%. Whereas the illicit case, the tax ratio between 12 to 17% looks reasonable. Domain experts from WCO prove date has some potential to achieve human-level interpretability. We also faced some challenges. As you can see in the bottom figure, average price of illicit transaction are 66% higher than that of a listed transaction. That's a huge difference. Since it was difficult to accept that this average price is so much different between 2 groups, so we ask Nigeria Customs that some initial feature values might be modified after the inspection. While our algorithm should have been trained and tested on all the initial values, there is some technical glitch in extracting initial value from their e-clearance system. Alternatively, for the undervalued import, which comprises around 3.8% of our data set, we use the adjusted values by rescaling their average price by multiplying with some random variable, and conducted some experiments to check the robustness of our algorithm. The revised data set has similar value distribution like this, so this is harder to predict. But luckily, we showed that the date algorithm performs reasonably well on this setting, the stochastic setting, so we expect that date will perform smoothly when the data pipeline is fixed. In this talk, we get to know the need for data analytics in customs and introduce the date model for custom selection problem. It ranks trade flows in the order of fraud risk and to maximize customs revenue. Date model has interpretability in nature because of its tree-aware model with attention networks. Based on its outstanding performance and interpretable nature, we expect that date can be easily integrated into customs administrations and assist customs auditors inspect the fraud risk of individual transactions. That's all for this talk. If you're interested in using our model, please check these links. This is the link for our GitHub repository. Thank you.